Gemstones are formed in different colors. The main reason for the coloration of gemstones is its chemical content. Every object showing its colors because of its particular chemical content. The white light plays an important role for the coloration of various objects. The white light or visible light composed of 7 spectral colors, also known as VIBGYOR. When white light enters into an object, it will absorb certain wavelength and transmit the remaining wavelength. The net result of the transmitted wavelength through that object will decide the color of that object. When an object shows red color, it means that the red color or red wavelength of that visible light transmitted through the gemstone unaltered, and the remaining colors or wavelengths absorbed by the object. That is why that object shows red color. When all the 7 spectral colors of white light absorbed by an object, that object shows black color. When all the wavelength or 7 wavelengths of visible light reflected by an object, that object will show white color. And when all the wavelength or 7 spectral colors passes through an object without any alteration, that object will be seen as colorless. That is why when we wear a black shirt, that all energy of white light will absorb by that black color, and we will feel very hot. It means that when an object absorbed the wavelength or radiation of visible light, that will cause for the conversion of light energy into heat. That is why black clothes creating heat to our body. When we are wearing white clothes, it will reflect all the wavelengths of visible light and we can feel some cool effect. When we look into the properties of gemstones, this same effect is occurring in gemstones. The main reason behind the coloration of gemstones are its chemical composition and absorption of light energy by the chemical content. Mainly the 8 transition metal elements will cause for the coloration of gemstones. These transition metal elements will have partially filled d shells. Some of the electrons in the outer d shells will be unpaired. These unpaired electrons, when receives some wavelength or energy from the white light, it will goes to the higher energy states because of the absorption of certain wavelength for the shifting of electrons from the lower energy states to higher energy states. Some colors are exhibited by the gemstone. The color of transmitted wavelength we can see as the color of that gemstone. According to the presence of transition elements in the chemical composition of gemstone, gemstones are generally classified into 2 types: allochromatic gemstones and idiochromatic gemstones. Allochromatic gemstones means when the transition elements are present as an impurity in the composition. Sapphire, ruby, emerald, etc. are the examples of allochromatic gemstones. In idiochromatic gemstones, the transition element is the main part of the chemical composition that is not present as an impurity. Malachite is an important example of idiochromatic gemstone. In ruby and emerald, the transition metal chromium is cause for the coloration. In this case, the unpaired electrons in the chromium element will absorb some sort of wavelength or some part of wavelength from the visible light, and that unpaired electron will shift or excite it to the higher energy levels. This causes for the red coloration of ruby and green coloration of emerald. Mainly the movement of electrons are caused for the various colors of gemstones. In some gemstones, some color centers are caused for the certain colors. Color centers divide into two types. One is electron color center and the other is hole color center. I can explain the electron color center by an example here. The purple color of fluorite gemstone is due to the electron color center. In the diagram, you can see that the fluorite ion displaced from the ideal crystal lattice, and that space is later filled by a extra electron from the valence band, and this process is cause for the purple coloration of fluorite gemstone. The brownish smoky color of smoky quartz is due to the hole color center. The chemical composition of quartz is silicon dioxide. When the Si4 plus ion replaced by Al3 plus ion, the electrical neutrality of the gemstone will be lost. For maintaining that electrical neutrality, a hydrogen ion or sodium ion will come to the crystal lattice. Due to the presence of hydrogen or sodium atom, the bond between the electrons in the oxygen atom towards its nucleus will be weakened, and some energy from the radiations like gamma rays and X-rays hit in that gemstone. The weak bonded electrons from the oxygen atom will displaced. This will create a hole in the crystal lattice, and then the unpaired electron in the oxygen atom will get some energy to shift to the higher energy states, and this is the reason for the brownish smoky color of smoky quartz. And in other cases, like in covalent bonded gemstones, you know that covalent bonds are created by sharing of electrons, and the free electrons in the outer shells shared and created covalent bonds can travel between the shared elements or ions. For the movement of electrons between the ions require some energy, and these electrons will absorb certain wavelength of light, and this is also some reasons for the color of gemstone. In iolite gemstone, you can see that the charge transfer between Fe2 plus ions and Fe3 plus ions is the reason for the blue color of iolite. And in some cases of sapphire, the charge transfer process between iron and titanium ions will occur. And electrical conductivity is also the reason for the coloration of gemstones. The gemstone or an object can conduct electricity by the free movement of electrons through the crystal structure or through the crystal lattice. Most of the insulator or non-electrical conducting gemstones are colorless in nature, and electrical conducting gemstones are all colored in nature. And in some cases, like semiconductors, we can say diamond is a semiconductor. Pure form of diamond is always an insulator. When impurity elements like nitrogen and boron present inside the or come inside the crystal lattice, it will start to conduct electricity. Because of this nature of diamond, it is considered as semiconductors. The type 2A diamond conduct electricity because of the presence of nitrogen impurities, and type 2B diamonds conduct electricity because of boron content. And rather than the process of or movement of electrons, many other reasons are also cause for the coloration of gemstones, like some optical properties like dispersion of light, scattering of light, interference of light, diffraction of light, etc. The chatoyancy and asterism of gemstones are due to the scattering of white light because of some needle-like or fibrous-like inclusions present inside the gemstone. When the light incident on that particular inclusions. Some effects like chatoyancy and asterism will seen on that gemstone. This is due to the scattering of white light. And properties like labradorescence and avengerescence, opalescence, adiolurescence, etc. is due to the activity of interference and diffraction of light. I think now you may get some idea about the coloration or cause of color of gemstones and other objects. Thank you.